This video, part 3 of Asteroids VR, will be relatively quick and covers the basics of the namesake asteroid obstacles. While setting up the project in part 1, you should have imported a small art asset package. If you look at this package's contents, you'll find a folder named prefabs that includes an asteroid prefab. So that it's easier to view the changes I make in this video as they are made, I'm going to drag an instance of this prefab into the scene. I found this model on cgtrader.com, where the artist was kind enough to offer it as a free download. In case you'd like to check out this model or any of the artist's other work, I'll include a link in the video description below. My test asteroid is pretty far away from where the game is actually played, so I'm going to reset its position to 0, 0, 10, which will be directly in front of the camera. We'll now create a C# script also named Asteroid, which will process and update the game object's transform over time. Each asteroid moves along its forward vector, the same way the player does. To avoid every asteroid facing or moving in the same direction, we want to randomize the way they face upon creation. Inside of start, create a float variable named y, and initialize it by calling random.range with a min of 0 and a max of 360. This float value represents the asteroid's rotation about the y-axis, and will be used to calculate the Euler rotation of the object when it's first spawned in the scene. Initialize the game object's rotation by creating a quaternion from the Euler angle 0, y, 0. By setting the x and z values to 0, we ensure that the game object will only rotate about its y-axis, and will always have a forward vector that faces some amount in the x and z directions, but never up or down, the directions represented by y. We'll use the forward to produce movement and update. This line should look nearly identical to the code we wrote for the player/camera's continuous motion, but the speed should be 15. You can use whatever number you like for this value, but I found maintaining an asteroid speed less than the camera's makes the game more fair and fun during gameplay. Instead of adding asteroid.cs to the asteroid game object in our scene, attach it to the asteroid prefab. This will automatically add the script to the instance in our scene anyways. When you test out the game in the editor, you'll see that each time you press play, the asteroid will move in a different direction. Our asteroids are still missing one thing though. They need to wrap around the playing area the same way the camera does. You can just copy the lines of code that handle this from the player.cs's update function and paste them into the bottom of asteroid script's update. And that's it for our game's moving obstacles. These additions form the foundation of our non-player objects and will be further built upon throughout the series. You can delete the test asteroid from your scene, as you won't need it after this point. If you haven't already, make sure to save your scene and project. Part 4 will cover the Asteroid Manager, which spawns multiple randomly placed asteroids at the start of the game and acts as an overarching system to manage all of them during gameplay. Thanks for watching, and see you next video!